Right. Okay, I think it's time. Hello. Good evening. This is Junichiro Horikawa speaking, and I would like to start the 101st episode for Houdini Algorithmic Live. And sorry for being late to restart the series. I have been doing the exhibitions with the designer Go Fukaji-san on Shibuya for 2 weeks, and it went pretty well, I think. A lot of people came to the exhibitions, thankfully, thanks to the great location, as well as people who found it interesting on the web. And I think it was pretty successful, and hopefully we'll be able to exhibit in other places as well in the future, which all the graphics in the exhibitions were made using Houdini, plus the pen blotter drawing machines. And because of that, what I'm going to show you today is the process that I took in order to create a data or drawing data for the pen plotter drawing machine, which I did on Houdini. So the process I took was to create, first of all, create a kind of a geometry inspired by the nature, then create a specific data which can be sent to a plotter drawing machine, which could be something like Axis Draw or a machine from the GraphTech, which usually creates a cutting plotter machine, but you can also put the pen to those machines to draw with these machines using any kind of pen you want. And in order to do that, you do need to create a line-based data on 2D to send as a vector data, which most of the time can be sent through software like Inkscape or Illustrator. So I'm going to show you the generic process, how you could create, how you could convert the 3D geometry to a 2D graphic, a 2D drawing graphic, then export it for the send into a pen plotter machines, and how I did for the exhibitions, actual exhibitions. Okay, so for today, first I'm going to create some simple geometry, simple animated geometry, something like this, a bunch of wires growing from one place like this. It's not really related to any kind of nature, it's just made it out of fun. So first I'm gonna create this simple animated geometry from scratch, then convert this into a line drawing based on some geometrical properties out of these out of this geometry that I created. Now there are many ways to convert this into a drawing, like you can create a hatching, or you could create you can plot amount of points on top of the geometry to use it for a drawing. But the simplest way, the easiest way, is to create the the line drawings for the plotter machine is to create a contour. So I'm going to show you how you can create a 2D contour out of this geometry throughout the process, which is already being taught in the last live stream using the same setup, I'm going to first of all create a 3D contour lines out of these geometries, then project this 3D information onto 2D plane so that you can export it as a 2D data. Let's wait for a little bit more to see the result. So first you get this kind of a three-dimensional contour data, but then in order to send this to a 2D data, you gotta flatten this onto a specific 2D plane. I'm gonna do that using a specific camera information. So from this camera view, what I first need to do is to trim out the backside of the curve. As you can see, you see that there is also a backside of the curve being drawn. So we don't want to really send that as a drawing as well, because it's gonna be really busy. It's gonna be really messy when you draw the backside as well. So I'm gonna show you how you can trim that out as well using some vex functions with small vex or small vector calculations. You can actually trim the backside out pretty easily. Now it's taking time because I'm making like as a high res image. Now that I have trimmed out the backside, as you can see, you can now project it onto the flat plane using another vex wrangle, using some kind of a projection code. And that's pretty much it. After you get this, you can just export it to some data format you want in order to send it as a 2D data. Okay, so that's the brief process that I'm gonna follow today. So let's try to do that. Let's try to create this process from scratch and see how I did. I'll show you how I did it. Okay. I got a comment, Axidraw is expensive. Any other cheapest device is recommended? Not sure. I thought Axidraw used to be cheaper. Maybe it's becoming expensive these days because of the low amount of transistors and so on. I don't have any options for the cheaper devices. Yeah, I don't really know. I used to use a machine from KNK, Click Uncut, the maker called Click Uncut, but it's it doesn't exist anymore. It doesn't make cutting machines anymore, so I'm not sure what's the best choice for these days for cheaper option. Maybe you could find one on AliExpress or something for cheaper options, but I'm not sure if it's feasible enough, I mean flexible enough to send custom data to draw any drawings. But let's see. I would also like to know if there's any cheaper options as well. Right, so first thing first, what I'm gonna do is to create some simple animated geometry. So some of you might find this part interesting, but it's gonna be really simple. I'm not gonna go into much complex stuff. What I would like to do is just to create some some network running from kind of animated geometry to animate the bunch of wires tangling like this from one place to another, following the path. Okay, so to do this, I'm gonna try to first create this path. Then along this path, I'm going to create a bunch of wires running around this basic path, right? So let's see how I can create this path itself. I mean, you could just use random or noise or any kind of stuff you want. Well, let's say that I would like to preserve the total length of the curve to something that I specify. So let's say first I create the line like this, and let's say the number of points is 100, and if I set the length to 10, and let's say I want to keep the length of the modified curve always equal to 10. So whenever I bend the curve, I don't really want to change the total length of this curve. Okay, so in order to do that, I guess one of the way you could do is to use a rig or KineFX from Houdini. So let's try to do that. I am going to first create the rig information, retrieve the rig information from this line using the rig doctor, which will create bunch of attributes which you can control on point wrangle, is it? And you also need to create or check the initialize transform so that you can control the transformation information from a wrangle. So if I look at the point attribute, you see now the bunch of transformation related to related attributes, something like local transform and transform. Okay, so what I'm gonna do is to control these transform to bend the curve to create a kind of a bended network which preserves the total length of the curve. Okay, that's what I would like to try out, and in order to do that I am going to use the rig attribute wrangle. Alright. So within this rig attribute wrangle, what I'm gonna do is to try to modify the local transform of each point based on the position of the point, or based on the maybe the parameter of the point, then bend it to some random direction, or maybe derive from the noise related value. Okay, so let's try this out, and in order to do that, first of all let's create some parameter value based on the point number and the total number of points. Now the point number is pt_num, and let's divide that with the total number of points. So that you get a value in between 0 to 1 as a parameter to define the position of the curve. Okay, so if the p is equal to 0, you get the start point. P equals 1, you get the end point. If p equals 0.5, you get the point at the half position of this curve. Right? Now let's try to rotate the local transform using pre-rotate function, and what I want to transform is the local transform attribute, which is the 4x4 matrix. Right, then in order to rotate this you need to specify the angle. So I'm gonna try to use the p as it is, maybe multiplied by pi for now. Then set some rotation axis, something like 1, 0, 0, which will be a x-axis, and see how it goes. Okay, nothing happens. Pre-rotate. And points, I'm not sure if, what did I do wrong? Let me check. What is this p-value? Okay, so p seems to be correct from 0 to 1. That's fine. Pre-rotate. Transform. Yeah, spell mistake. Okay, now I got this rotation. And one thing I want to make it clear is that if the total length of this rotated curve is equal to the original length of the curve is equal to 10. So let's create a measure node. Let's see. Measure node, and what I want to measure is the parameter. Right. Go back to the primitive rank attribute, and yeah, the parameter is equal to 10, so that looks fine. Now let's try to control some of those values. Maybe the angle right now is a bit too much, so let's make it really small, like 10 degrees. And you get this kind of curve, which is fine, but it's not really interesting. So let's also try to change this axis based on the parameter positions. And it might going to be interesting if I make the this axis random. So let's try to do that. But in order to rotate this curve, I think it is always a good idea to use the normal direction of each curve as the axis. So starting from the straight line, I think it's not really a good idea to use the y direction in this case as a rotational axis, which won't do anything, right? So keep that in mind. Let's try to create some axis-based value. Vector axis is equal to noise, and based on the, could be based on the positions, could be based on this parameter. Maybe using parameter is fine, since this is just a straight line. Doesn't really make any change. And let's also multiply this by some smoothness value to control the noise smoothness. Right. Now as a result you get a vector value, which is in between 0 to 1 for all x, y, z coordinate. Now what I want to do next is to make the y value equal to 0, so that the vector value is always on a 2D plane. As well, right now the coordinate range for x and z is in between 0 to 1, so I want to be able to create the negative value as well. So first I'm gonna subtract by 0.5 for all x, y, and z, so that the range becomes minus 0.5 to 0.5 for all x, y, and z, and make the y value equal to 0. Okay. And one more thing you should do is to normalize this axis, because if you are not using the normalized vector value for this axis for the rotation, the actual rotated distance, rotated value, or rotation transformation will change the distance as well, the scaling as well, if it's not normalized. So it's always better to make the axis value normalized whenever you use it for the axis for the rotation. Alright, so let's promote the smoothness value and see what it does. Okay, spell mistake again. Okay, maybe the range is not too big. Let's make the smoothness range till 10. Let's see what happens. Starting to becomes a bit more interesting curve. Alright. Alright. Looks interesting. Right now the angle becomes larger and larger this way. So starting from 0 and end at 10 degrees. If you want to use the constant angle, you can remove P and will become more exaggerated. But I think I would love to have a gradient angle. So, and instead I am going to be able to change this as a parameter. Which is a degree based value, so let's make it from 0 to 180. This might be too much. Something like this might be interesting. And I think it also might be a good idea to control the how fast the P goes from 0 to 1 when you want to use it for this multiplication. So let's create another parameter in order to control the new P using ch ramp. And replace this P with NP and try to use this curve to control how fast the angle will change based on the x position. You see some more interesting results starting to happen. Well, this is just a path, so it could be just like anything you want. What I want is to start from a straight up, then try to have some interesting road. As much as possible. Okay. Seems could be interesting. I don't know. I mean, there are no like best answers for this. It's just a matter of your taste. So let's say I'm good with this. Good with this path. Now what I'm going to do next is to try to create a bunch of wires wrapping around on top of this base path curve. Okay, so let's try that. Okay. So first thing first. In order to wrap around the curve, bunch of curves on top of this core curve, it is a good idea to calculate the normal direction as well as the tangent vector direction to each of the point on top of this curve. So you have a bunch of points on top of the curve, and if you have a tangent vector and a normal direction vector, it will be much easier to place another curves on top of this core. So let's use a orientation along curve, right? Which will create a up and normal. And the normal, if I show up the normal direction, the normal is actually the tangent vector. Alright. So I'm guessing the up vector is the actual normal direction of the curve. Let's visualize that. Let's make it a vector. Alright, so yeah. So you have two vector information. One is the tangent, one is the normal. So let's rename this so that I could understand it more. I'm calling the actual tangent vector as tangent and normal direction as n. Okay, which makes it more clear to me. Alright. Now that I have those informations, the first thing I want to do is to create some randomly wrapping curve on top of this core curve with the number of your choice. So I guess there are many ways to do this. Maybe the easiest way is to use the for each number to define how many curves you want to wrap around this core, deciding at here how many iterations you want to get, how many iterations you want to calculate. I'm going to create the null node to store all the parameters that I would like to control later, just as I do many times. Let's name this number 0 to 100 and copy the parameter, paste it into the for each number. Okay, so you have right now you have 34 iterations for this for loop, meaning you are going to get 34 curves wrapping around this core, right? And in order to do that, for each loop you get the core curve, so you are just going to move this curve, offsetting this curve to random direction using these normal direction as a guide. Alright, so in order to move the point position, offsetting the point position, I'm going to use the point wrangle, and for each iterations I want to make the moving direction random, so I'm going to refer to the metadata which stores the iteration related value, which is this one, iteration at detail attribute. So let's try to do this. First, I'm going to refer to the iteration value from the detail attribute coming from the second input, just this one, and the value was called iteration, starting from 0 to 34, maybe minus 1, so 0 to 33. Right? So based on those values, first thing what I want to do is to create some random value in between 0 to 1. Using randomness, random function, using iteration as a seed, and let's multiply it by some constant value, as well as adding with some parameter of your choice to use it as a random seed. Okay. As a result, you get the value in between 0 to 1 out of this. And I want to remap this 0 to 1 value into an angle based value. in order to choose in which direction you want to offset these points. Right, so in order to do that, I'm just going to multiply this value with pi multiplied by 2, so that the random range becomes 0 to 2 pi, which means 0 to 360 degrees. Right? And oops, rand value. Okay, now that I have this random angle value, let's try to create the rotational matrix to rotate, in order to rotate this normal direction that we have right now, in order to use it for the actual direction to move the point. Okay, so starting from creating the identity matrix, rotate this identity matrix by this random angle, and the axis is actually the tangent vector, which you should be able to access by calling the tangent vector value, this one. So the axis itself will become tangent. Right. Now that I have created the rotational matrix, it's time you could rotate the normal with this matrix. And after you have rotated the matrix, you can now move the point position along with this normal direction. So let's try to do that. Offsetting the point to the normal direction, multiply by the amount of offset. Let's try to make it as a constant value for now. Right? And if I make the seed value, you can see that the direction is randomly changing. And if I make this offset value increased, you see that the curve being offsetted to the normal direction. And for each iteration, the direction will change. So as a result, you get a bunch of curve wrapping around the core curve. Now the problem is the distance, the offset value is always equal, always constant. So you are seeing some kind of a pipe-like shape, which doesn't really look interesting at all. So I want to make this offset random as well. And also the direction is also looks too constant. So I also want to add some maybe noise related value to the angle, to this base angle as well. So in order to make it a bit more interesting in terms of the wrapping. Right? So first thing first, let's try to change the distance value. Okay. The distance value, maybe it might be a good idea to use the parameter of the curve to use it together with the noise based value. So in order to change the offset, you need to modify this one right here. So let's create the variable called offset, starting with this offset value. Replace it right here with the variable and multiplying it with noise value. And for the seed for the noise, I would like to use the parameter for the curve. So again, just like we did last time, I'm going to create the parameter value p by dividing the ptnum by number of points. minus 1, so that you get the value in between 0 to 1 in float. So this is a parameter value. And I want to use this P as a seed value for the noise. Then multiply some smoothness value to control the smoothness. Right. Now I think it also makes sense to change the variation based on the iteration. So let's also add iteration related value and multiply it with really big number in this case. If you are using noise function, the distance matters compared to the usual random functions. The random function doesn't really matter about the distance between 2 points, but if in terms of if you are using this noise function, if the distance is close to each other, the value becomes closer as well. So if you want to make random in between different iterations, you want to multiply it by, you want to add it by really high number. Okay, and might not be a good idea to use the always 0, so something like this. Okay, and change the smoothness, and let's see if I'm seeing some changes here. Okay, I think I am seeing, but maybe the smoothness is a bit too small. Let's create the range from 0 to 20 and see if I can make more variations. Okay, something is changing, something is not changing. I might see some caches. So in order to remove the cache, you can go to the window. Nope, I don't see it. Used to be a reset viewport somewhere. I don't see it anymore. Maybe I need to install the side effects labs. I'm right now using 19.5, so that might be the reason. Oops. Okay, no Houdini launcher found. How is that possible? Okay, never mind. Let me check the name of the application. Oops. Okay, well, I do want to use the side effects labs, so not sure why this is wrong. Looks correct. Maybe it's not a valid launcher path. Is it? Application. Not sure why. Okay. Now, why did I launch this? Okay, forget it. I'll just do it later. I want to make sure if I'm seeing the cache or not. Maybe not. Okay, some curves are changing, some curves are not changing, for sure. And I want to know why is that. And now seems to be a little bit better. Okay. Now, when you use the noise function, the range is normally in between 0.3 to 0.7. So let's use the fit function to the noise value. And clump it to 0.7 to 0.5 and remap it to 0 to 1. So that you have more exaggerated result. Okay, looks better. Alright, I think I start to like the result. Looks nicer. Okay, getting better. How's this? Okay. So, number of lines looks good. The offsetting setup looks also good as well. Maybe I wanna add 1 to this iteration, and also add multiply by some seed related value. Alright, just in case you want to change the variations. Oh, wait a minute, I already have seed, so seed 2. Okay, now so far so good. Next thing I would like to do is to try to change the angle as well using some noise related value. Right now I'm just changing the offset distance. Just changing the offset distance looks okay, but I don't see any like weaving pattern yet. So I do want to see some weaving pattern with these curves. So in order to make it more complex, I would like to change this value, this angle value. And in order to do that, I am just going to add additional angle related value derived from the noise. And I could probably copy those line here, paste it right here, and use the different value, smooth 2 and seed 2. Well, I'm just gonna keep it as the same C2 for this one, and just try to change this value for a little bit. And what else? So by doing this, you'll be able to get the value in between 0 to 1 out of the noise. And what you want to do is to change this to an angle related value. Okay, so maybe I could just change these minimum and maximum value to change the angle. So what can I say? What should I say? Or just multiply by some maximum angle of the change. So angle, I'm gonna just create the angle parameter, which might be better to make it as a degree based value. In order to understand the user to what kind of angle you want to input. So let's make the maximum 360 degrees and see what happens if I increase this. Now you are seeing the turning to the curve, and the curve starts to weave together. Now it might be better to have the negative directional angle as well in this case. So after all, maybe it's better to bring this to the maximum and also the negative value to the minimum as well, which will create more randomish angle. I thought it would. No, it's not doing. Where did I do wrong? It's not really changing anything. It's just changing the first curve. Interesting. Not as I intended for sure. Okay. Maybe the number of parentheses is wrong. How come? Well, I'm gonna keep it 0 to 1 here. See if this works by multiplying the angle again. Okay, it's changing, so I don't know what went wrong last time. It doesn't really look smart enough. How come it didn't work last time? If I replace this with this angle here, does it work? Okay, it does work here. Now if I place a negative value here, okay, it is working right now. Oh, wait a minute. No, this is the value I want to change. Okay, now it's not changing. So maybe something is wrong with these values. So P. I'm gonna break down to some small portion. Noise value is float, which is equal to this noise related value until here. Right, and replace the noise with N. Still seeing some weird effect here. Why is that? Maybe this is too big? Probably. Maybe this value was too big. In those cases, maybe I should make this smaller as well. Okay, looks a little bit better than before. Okay. All right. Wait a minute. Wait a minute. Actually, my P is always starting from 0, so might not be a good idea to include 0. So I'm gonna start from 1. Alright, looks much better now. The starting point also rotates now. So maybe I should do the same things for this one as well. Okay, looking better. Looks better. And I also want to increase the smoothness to range. Okay, starting to get more complex. Okay, looks good. Starting to have more weaving effect here. Alright, so let's say I'm good with this for now. Okay, maybe I wanna increase the offset a little bit more, like that. Okay, so it's time to create a pipe, to run through the pipe, but in order to avoid the self-intersections or the intersection between the pipe as much as possible, I'm also going to use the node like detangle to have the space in between the curve, the closest curve. Okay, just as an option. Okay, so detangle curve won't work as it is. You do need to provide the rest positions. So I'm going to use the rest position node. Now the problem is the moving speed is a bit too fast with the first iteration of the detangle when the thickness is too thick. So let's say 0.05 is okay, but in order to make the line network a bit more smoother, I want to connect the smoothness. But as soon as I connect the smoothness, the problem is you start to have you start to have the intersection again. So to get the best result, you are going to, the best way, or one of the good way, is to run this setup many times recursively using the for loop. So I'm going to change this to feedback loop so that the same process runs after the previous process has ended. So meaning this means that you are running this process 10 times based on this iteration number. So if it's 0, nothing happens. 1, you start to see some separation between the curve. And more number you get, more optimized position you get to have the space in between the curve, so that you are avoiding the self-intersection or the intersection between other curves. I think you still have some intersection between the curves, but it's okay. It's just a test geometry, and it's not really for the product or anything. It's just a virtual geometry. Now connect the polywire. Increase the divisions to something like 16 to make it a bit smoother. And I think it is always a good idea to derive the radius based on the relation between these detangle value 0.05. So let's link those two values together using your own thickness value, or maybe the pipe radius. From 0 to 0.1. Okay, copy this parameter, paste it to right here, Now since this is the radius and it's a bit hard to see, so let's connect normal. And let's also paste the radius to the detangle. And as you can see, you do see a lot of intersections. You still see a lot of intersections, so if you really want to avoid this, you should increase the iterations a little more. But it depends on your needs. I think I'm okay with something like 20, and maybe it's packing too much, so maybe I can increase the detangle distance to the double number of the radius. Okay, in this case maybe the iteration is too high, and maybe the offset number is also too high. Well, it doesn't really matter. Or the number of pipes is not well, I do want to increase the number of pipes, so I'll just decrease the radius to 0.025. Okay, it looks much nicer. Right? Maybe increase this a little bit more. Yeah, something like this. Okay, starting to have nice wire geometry here. Now that I have this complete geometry, what I want to do and what I'm going to do next is to create the animation from the end result. So just like reverse engineering to create the fake animation to make this grow. It's already been grown to the end, but in order to create the animation I can go back to the first positions, then try to create the fake animation, which seems like the wire is growing to the end from this result. Alright, looks good. I think I like the look of it. Some self-intersections here. Maybe I can increase a little bit better. Okay. Now, in order to create the fake animation, it's better to go with the curve first, right? So what I want to do is to grow the length of each curve starting from length equal to 0 to the final length, and probably changing the speed rate or the starting growth time different for each curve might make the growth animation a bit more interesting. So let's try to do that, shall we? Now before doing that, I am going to make this curve a little bit smoother, since as you can see right now it's a bit too polygonish right now. Polyline looks a bit too polyline, so I want to make it a bit more smoother using resample node. Controlling the length of the separation, and also change this to subdivide curve or interpolated curve, whichever you want. Okay, and looks a bit more smoother. Maybe too much point for now, but it's okay. Alright, let me save this to the desktop for now. Alright, now in order to make this grow, each curve grow from 0 to the full length, the easiest way is to use the carve node, which you can use to trim the curve using these parameter value but everything is changing with the constant speed, as you can see. So if you want to control each curve one by one, you need to use together with the for each primitive, which makes it really slow to create the animation. So I don't really want to do that. What I want to do is to use the vex way. There is a function you could use to trim the curve inside a primitive wrangle for each primitive, using the vex code, which is stored inside the external library, which is shipped with default installation of Houdini. So let's import that library, which is called groom.h. Right, and inside this library there is a function called adjust prim lengths, I think. Let me check. And looking at the error, okay, it says no matching function for adjust prim lengths. Candidates are void adjust prim lengths. So it does exist, but the parameter is wrong. It is integer float. So this is the geometry input number, this is the primitive number, this is the original primitive lengths, this is the new primitive lengths. Okay, you have 4 parameters. The geometry input is always equal to 0. The second parameter is the number of primitives, so prim num. The length of the curve is, since we have changed the offset value, it's no longer equal to 10, so let's recalculate the lengths using parameter with the measure node. So for each primitive you get the lengths. Okay, it's close to 10, but somehow a bit different for each one. Alright, going back to the primitive wrangle, refer to this parameter and the new lengths should be smaller than the parameter, so multiply by some float based value and see what happens. So right now it's equal to 0, so nothing shows up. If I increase this, you see that the curve is growing. Now since this is the function inside a primitive wrangle, you could apply different starting value or different s value for each primitive. So that's what I would like to do. Okay. So let's say the animation goes from 1 to 240. What I could do is to change the timing when to start, when to make this curve start growing. Okay, so just like I do in other examples as well, let's try to do that. First thing first, I'm gonna create the start frame value, which is per primitive. So I'm gonna create a random value based on the primitive number, multiply by some randomish value together with the seed. Okay, which will give you a value in between 0 to 1, and I want to multiply it by the maximum starting frame range. So let's say if I want to make all the curve start to animate within from 1 to 100, then I want to multiply 100 right here. So let's create a parameter in order to control that value. Let's call that start frame and make this 100. Now you are getting a value in between 0 to 100 with this calculation, right? And I want to use this as a offset frame value in order to determine when to make this curve start growing. Okay, so since I want to make it as an integer, let's make it as a ceiling so that the frame value, start frame, will be always start from 1 to maybe 101. Okay. Now that I have this value, it's also a good idea to define the range. So if it started from 100, then the range you are left out with in order to make the curve grow is 240 minus 100, so 140 degrees. So let's also calculate the frame range in order to make the curve growth. This is when you are expecting all the curve to move in same speed, constant speed. But if you are okay with changing the growth speed for each curve, then there are other ways as well. Okay. Now that I got this range, let's try to create the actual value in order to start the curve growing. Okay, so instead of this s value, parameter s value here, I want to create it as a variable. And what I want to do is to remap the current frame value, which could be 1, 69, 140, 54 or something, and the minimum is start frame. So if the frame is less than start frame, then you are always using the minimum value for the remapped value. And source maximum is start frame plus range. Okay, and I'm gonna remap to 0 to 1. So if the frame is less than start frame, it'll always become 0, so you are not seeing any curve growth. And if the start frame goes over start frame plus range, then the value will be clamped to 1, so that the curve is going to stop growing. Okay, now that I have got this value, let's replace that s value with this constant value and see what happens. If I play it, wait a minute, I think I need to define the start frame. Okay, let's set the start frame range to 0 to 200, and let's set it to 100 for now and see how it goes. As you can see, some of the curve are growing faster than the others. Some of the curve start growing later, like that. And every curve is growing at constant speed. So that's that. Now if you also want to change the growth speed as well, then this is where you need to change range, right? Now this could be the maximum value, or let's see. Well, actually it is not growing at constant speed as I thought. Yeah, since I'm using the start frame for the range, it is not a constant speed as I thought. In order to make it as a constant speed, I need to make this value constant. So using something like this one instead. Right. So if I place that here, now the speed will become constant. Alright. So whichever you want. If you want to make it constant, you do it like this. If you don't want to have a constant speed, then you can make this as I don't know, the slowest frame speed, and define some random value again. Based on the primitive number. If you want to change the speed randomly for each primitive, I'm just gonna copy all these. And change the seed a little bit. And since this is in between 0 to 1, I'm going to use the fit 0, 1 and remap it to maybe the range multiplied by 0.25 as a minimum and the range itself as a maximum. This will change the speed, the growth speed for each curve. Some curves grows really fast, some curves grows really slow, so on. Maybe that was too fast. Let's make it 0.5. Okay. Might be okay. Alright. Now I think I'm okay with these. Now that I have this animated curve, you can start seeing in 3 dimension as well. Maybe this is too slow to check. I'm going to make this resample to be a bit more larger. And I am getting hungry. Alright, looks better. Looks nice. Alright, now this itself is okay. It looks like it's growing, but I want to make it a bit more like I don't know, like muscle fiber stuff. So maybe I'm gonna assume that there are some blood running inside this each wires. So want to make some kind of a pump-like effect to each of the curve as a addition for fun. So shall we do that? In order to create that kind of effect, what I would like to do is to control the P scale for each point, for each primitive, for each curve, right? So to do that, it might not be a good idea to do inside primitive wrangle, because what you want to do is to control the point attribute for each point. So instead of using primitive wrangle, I'm going to use the point wrangle after this. So point wrangle. And I'm gonna call this pumping effect. And let's write some simple code here. So again, I want to differentiate the pumping rate for each primitive. So from each point, I'm going to retrieve the corresponding primitive number using point prims, getting the first primitive number, since I think each point exist only on top of the single primitive. Now let's create the p-scale value, animated p-scale value, by using the noise. And since I want to make some offset for each primitive, I'm going to multiply the primitive number by some big number like 10,000, then subtract it by a parameter of each curve. Now I don't have the parameter yet, so let's create that parameter, which is again ptnum divided by endpoints 0 minus 0.0, and you get the value in between 0 to 1, and use this parameter, multiply by some, again, the noise smoothness. And if you want to animate this, you also need to include the frame based value as well. So let's have this frame inside a noise, multiply by another parameter. Let's call this speed. Right. As a result, you get the value in between somewhere around 0.3 to 0.7. So let's also remap that. 0.3 to 0.7. Remap that into the minimum thickness or minimum radius to maximum radius. And apply that as a p-scale. Alright, okay, some errors here. Okay, the smoothness could be really big, I think. Let's increase the range to 100. Speed, I'm not sure. Maybe from 0 to 1 is fine. The minimum radius and the maximum radius range, I'm not sure. Maybe set the range between 0 to 3. Okay, so let's see. Let's set some random value here and see what happens. Okay, if I play it, okay, nothing seems to happen because I am not using p-scale at all yet. So let's do that by maybe multiplying p-scale here. Okay, in those cases, maybe the minimum could be 1, the maximum could be 2, and see what happens. Okay, now you can see some kind of a pump-like effect. Right. Looks interesting. Maybe I want to make it more noisy. Maybe that was too noisy. And I realized that at this point, since the parameter always get the value in between the whole curve from 0 to 1, so in this case this is getting too noisy. Yeah, I don't really like this. Yeah, so instead of using p-value, parameter p-value right here, I would like to calculate this value before trimming the curve somewhere. Maybe I can use the resample node to promote the curve u value, which is equal to the parameter. So each point has the value in between 0 to 1 for curve u. Okay? And the curve u still exists inside this animated curve. So instead of using P here, I can just use the curve U. Alright. I think that will make this better. Okay, and I can see that it's pretty noisy. Maybe I should decrease this value. And I can increase the speed. Maybe that was too fast. Somewhere around here. Okay. Starting to see more like a creature-like shape or creature-like animation. Yeah, kind of like it. Alright. Well, it's not really related to the plotter drawings, but I mean, whatever you do, you want to create something interesting for yourself. So for myself, this things is somehow interesting. So yeah, okay, I think I am good with this. Right, so now that I have this final geometry in order for the plot drawings, let's try to convert this into the actual line drawings finally. Okay. So till here I was creating the geometry. And let me also promote all those parameters that I set, which looks important. Okay, I think I took too much time to create this kind of shape. It's not really important. The lengths might be important. These rotational related value is also important, I think. Pipe bend smooth, pipe bend angle. Also these ramp as well. Right, what else? Measure node. Okay, so number of pipes. This is, I think this is important. We already have that. And number of detangling. I don't think I need to make it as a parameter. You can just do it by hand. Resample curve. This is kind of important. Pipe resample. By changing this value, you are also changing the quality of the final line drawings as well. So it's kind of important. And what else? Animate. Yeah, I would also need those as well. What was S? S is just a constant value, which I'm no longer using it. Seed. Seed, I'm just gonna leave it as it is. Start frame, maybe. Okay, pump. Yeah, this is also, I guess, important. So pipe, pump, smooth. Speed. I think I'm missing some parameters here in order to change the the offsetting values of this pipe. I think it was inside a for each loop. Pipe, pump, speed. And this is the minimum radius. This is the maximum radius scale. Pipe max rad scale. It's too long. Okay, going back to the for loop. This one offset, you have a bunch of parameters. This is also important. So the seed, okay, I'm just gonna skip the seed. Offset, right, so somewhere around here. Pipe offset. Smoothness, pipe offset, smooth, was it? Yeah. Pipe offset, smooth, and C2, I'm gonna skip it. Smooth 2, what was it for? This is for the angle, right? Pipe, I'm just gonna call weave, smooth, pipe, weave, smooth. And this is the weaving angle. Pipe, weave, angle. Okay, guess that's pretty much it. That was a lot of parameters here. Now this is all really geometry related. So let's create a separator. Okay, now the next step is to start creating the curve related geometries on top of this original geometry. As I said, there are many ways to create the curve on top of this curve. One of the way you could do is to like create a hatching, put a lot of points and place like circles on top of these curve, on top of these points. But the most used process is to create a contour on top of this geometry. Okay. So what I would like to do is to create contour running this direction, this pipe running direction. Bunch of contours to this direction wrapping each pipe. Okay, that's what I would like to do. And I guess there are many ways to do that. Hello everybody. But the way that I'm going to use is the step that I told you last time on the last live streaming video, which the topic was to create the attribute based isolines. Okay, which you can find from YouTube. Let me check where that is. Just referring to my own video. Where is it? Where is it? Okay, so this one. So in the Houdini Algorithmic Live 100, I have told you how you could create the ISO lines based on the attributes on top of the geometry. And I'm gonna just use the same process here in order to create this ISO line and use it for contouring the geometry, which is pretty useful for any kind of geometry. Once you have any kind of attributes, you can create an ISO line or contour line, something like this. So you'll be able to create a really customized ISO line by yourself, for yourself. And later I'm going to actually customize your attributes to create a bit more stylized line network or a drawing. Okay, so I can just copy and paste the one from the last, but might not be interesting, so I'm gonna just create from scratch, which isn't that hard to do. It's not a big line of the code, but I'm gonna skip the explanation a bit, why this actually works. Okay, if you want to know how it works, then go back to the last video and check it out. Alright, so first thing first, what I'm gonna do is to create the attribute on top of each geometry, which is going to be used to create the contour lines. Okay, so, and it could be a point-based attribute, or it could also be a vertex-based attributes. Now, what I would like to do, what I would like to use here is, since I want to create a equally spaced contour lines on this direction, and since this is on top of the pipe shape, which has this round section, I think it might be a good idea to just use the UV information on top of this pipe, which is already being created together with the poly wire, to be a base attribute for the contour lines. Okay, since it is already wrapping, the U value is already wrapping from start point to the end point from 0 to 1. So I guess I'm gonna choose the vertex based attributes to create the ISO lines here. So to do that, first I am going to create this attribute retrieve from the UV value. So vertex wrangle and UV map. What I'm gonna do is to just retrieve the UV.x, which is the U value, and apply it to a single float value. That's it. Just gonna copy. And let's see how it looks like looking at the vertex attribute now that I have this value here, which should be in between 0 to 1. And let's check how it is being distributed using color node. So change this to vertex, run from attribute, change the val, change the color to something understandable in Felno. Okay, so starting from 0, which is this stock black color, going to this direction, wrapping and end at 1, which is this yellow color. So looks good. I think I can use this value attribute, the attribute called val, to create a contour lines. Alright, so let's forget about the color node, and next thing I would like to do is to get the minimum and the maximum value of this attribute. But since I know that the value is in between 0 to 1, I'm just gonna assume that I know the minimum and maximum for now. Okay, and now it's time to actually create the contour lines using primitive wrangle using coding. Okay. Now this, in order to create the contour line, I do need to code a little bit. So let's do that. It's going to be a little bit long, so please keep that in mind. First, I'm going to define how many contour lines I want using the parameters. Let's say I want to create like 30 lines for each pipe. Right? And I am going to get the minimum value for the attribute, which right now I don't have it inside the detail attributes, so I'm gonna assume that I know the minimum maximum, which is in between 0 to 1, since UV is in between 0 to 1 in default, so I think this assumption is correct. Alright, now I'm gonna create the for loop. First loop is in between the counting the number of ISO lines. Okay, and there's also a second loop which counts the number of vertices for each primitive. So let's get the vertex list from each primitive. Right. Then loop through each vertices. Right. Then I'm also going to create a variable called sval, which is going to be the parameter value to define in which. So if I'm looking at this, oops. If I am looking at each primitive, what I would like to know is in which edge I would like to cut. So in this case I want to go in this direction, so I want to cut in this direction. I want to use this edge and this edge to add the ISO lines. And in order to define in which position of the edge that I would like to use it as a cutting line or cutting point position, I need to calculate that right here, and based on this number value. Okay, and in order to assume the parameter value, what I'm gonna do is to remap the n, which is in between 0 to number, and change it to a value in between minimum value and the maximum value. Okay. Right. And the s value is the reference value, which is in between 0 to 1 right now, and I'm going to check if this s value is within this edge. Within this edge you have a val, the attribute called val, which is derived from the u value, and if this val is in the range, if the minimum value here and the maximum value here in this range is the s value is included, then you can add the ISO line within using this code. So that's the rule. And let's check. Now I got the I got the number of vertices like this. Okay. And prim num. Right? For each vertices, I am going to check this edge to see if the S value could be included within each edge. If it's included, then I could add the lines. Right, so BT1 is and get two vertices next to each other. Like this, and in order to get the value attribute, you are going to use the vertex function for each vertex number. Alright, now in order to define the cutting point position, you also need to know the vertex point position as well. So you get a point number out of the vertex first. And copy this to get the point 2. Get the point position for PT1 and PT2. Position 2 is equal to 0.0 p PT2. Alright, now I am going to use some conditions to see if this S values is included within this edge range. Okay, to do that, the condition looks like this. If S val minus value 1 multiplied by S value minus value 2 is equal to 0 or negative, then that means the S value is included within value 1 and value 2. Okay. And if that's true, then I'm going to specify the actual point position within the edge by first of all calculating the factor from the starting point to the end point. If it's 0, then it is at the starting point. If it's 1, it's at the end point. If it's 0.5, it's at the center of this edge. In order to calculate that, I'm going to fit the S val, which is in between the value 1 and value 2, and remap it to 0 to 1. Alright, and from this I can now calculate the point position by using lerp between the position 1 and position 2 using this f. Right? And you can now use this to add a new point. Now in order to create the line, you also need to have the other side as well. So assume you are going to get at least 2 point. I'm going to create a array which stores all the positions that I found as a new point. Now that looks like a lot of coding, but it actually is pretty simple if you think about it, for what you get in a real-time speed. Because if you try to get this kind of a contour, and later on I'm going to make it more customized, it's gonna be really hard to do with nodes, existing nodes, I think. So now that I get this appended array, it's time to go look at all the arrays, look inside arrays, and try to start creating the lines, the ISO lines. Now I am assuming that there is at least multiple of 2. The number of positions stored inside this array should be multiple of 2, because you always need a pair in order to create the lines. So this is just an assumption, and I'm not really sure if this is correct or not, but I'm going to skip the second one to get the positions, so that I can get both position 1 and position 2, which lies next to each other. Like this, right? Now there might be a chance that it goes over the total number of the positions, and so in those cases I'm going to make sure that it goes back to 0. Hopefully it will not. Now let's create a new point out of these new point positions. BT2, position 2. Okay, now that I have these 2 points, you can now connect those 2 points together to create the line. And I have got errors. This should be new pause. Okay, now if I look at it carefully, you see that the line has been created just as I assumed. Okay, it looks good. Now I don't really need the original geometry anymore, so let's remove it. I mean the pipe geometry. There you go, and I am all left out with those contour lines on top of this pipe shape. Okay, looks good. Now, and if I control the number of contours with these parameters, should be able to get as much contour line as possible. And as you can see, it's not really slow, it's pretty fast in order to create these lines, bunch of lines. Now since this is just a test, I'm going to go with a really low number of lines, something like 30. Alright. Okay, now I have those bunch of lines with bunch of contour lines. The next thing that I would like to do is to create or trim out the backside of the curve so that I can only see the front side, so that I can later on then projected onto the 2D plane to be sent to the plotter drawing. Right? Now that's kind of a main part of this stuff. Now before doing that, I'm going to clean these contour up a little bit using fuse to remove the duplicated points. Okay. And then I'm gonna make it as poly wire, or no, poly pass to connect all those separated lines together. Poly path. Like that. And just to make these curve a little bit smoother, I'm going to apply some smooth node. Like that. Maybe I don't really need this part. Okay, I do have some funny shape here. What's that? What's this? Okay, I guess it's due to the fuse. Maybe if I can decrease the snap distance. No, doesn't really change. Let's look at the original contour line. Funny. Where does this come from? Well, what if I increase the snap distance? No, that's not good. Okay, I assume this happens at the UV equal to the UV's U value equal to 0 or 1. So let me check that by checking the color. Okay, I'm lost. Okay, where was it? Okay, it's a bit hard to see. Where is it? Okay, here you go. Here you go. This branching, where does this happens? Yeah, possibly where the U becomes 0 to 1. That's where it happens. So the best way I could think of in order to resolve this problem is to skip adding lines on top of the U equal to 0 or 1. Right, so what I could do is to make this smaller. And that way the curve will never be created on top of the edge. So I mean along the on top of the vertex. So in some cases that might create some problem, but in this case I think it works good. Oh, but there is a problem here. Okay, so maybe I still need this. Yeah. But so maybe what I could do is to create some offsetted value to this S-val. So let's see what I could do. Maybe I could make this maximum value a little bit smaller than 1, or make this minimum value a little bit bigger than 0, like this. Yeah, there you go. A little bit better. I do have some space here, not sure why. That is because I have this. Yeah. Okay, a little bit better. Maybe I can also subtract this a little bit small with a small number, just in case. Like a tolerance value. Okay, looks better. Overall, I don't see any problems right now anymore. So let's go with this. So this is the ISO contour, ISO lines. This is also related to the contour lines. Okay. Now, the trimming part. In order to trim out the curve, okay. I just look at the comments and I see a lot of spam messages. Let me just delete those. How's this? Okay, that should do the job. Okay. Where was I? So let's trim out the curve. And in order to do that, what I need is first of all the camera positions, the camera perspective, angle, and so on. So let's get all those informations by first of all creating the camera itself. Okay, let's look at the camera. Let's see in which direction I want to see this geometry. It's a bit hard to see with all these lines. Let's go back to the geometry and see. Let's check. Now what I would like to test out is those like hiding part also appears. So in order to get the front side and delete the back side. So I do want to have some kind of overlapping to each other, self-overlapping. Maybe something like this. Could be interesting. Okay, so let's say I am good with this view. And what I'm gonna do is to try to get this view, use this view to trim out the backside of the line, backside lines, and also flatten into the 2D plane using this view as well. Alright, so let's do that. Going back to the line information. And in order to trim out, oops, what's this? In order to trim out the lines, what I'm gonna do is the simplest way that I could think of is to convert each line convert this polypath into a line again, back to line again, and delete the line which is at the back side. That's the easiest way I could think of. I mean, so in order to make it clean, in order to trim out in a clean way, you do need to have a lot of resolutions, a lot of points, a lot of lines to do that. So that might be a problematic if you want to have a lightweight processing, but right now the easiest way I could think of is just to convert all the polypaths, polyline into the lines and delete those lines on the backside. So I would like to go in that way. So first converting to a line, back to a line again, and check if the line is on the backside looking from this camera. Okay, so to do that I am going to use again some wrangle. primitive wrangle. I'm going to look at each lines and see if this is at the back side or at the front side. Now, in order to check that, you do need to calculate some kind of intersections between the original geometry, which could be this one, right? So this is the original geometry. Let's connect this to the second input. Okay, and let's call this trim backside. Now, first thing first, I need to know the camera position and camera direction in order to create the intersection test. So in order to get the camera direction, first you do need to know the path for the camera. So cam path is I'm gonna create a parameter. Now this itself is a bit hard to input, so I'm gonna change the parameter type to a operator path. Now you can use this UI to choose the camera for yourself. Cam 1, alright. Now that you have a camera path, next thing you want to do is to get the camera matrix out of this camera information. So to do that, first create a variable called camera matrix, and actually you can get that by using the function called op transform. By using this you can get the transformation matrix out of a specific operator or node. In this case you want to get the transformation matrix from this camera node, so you do it like this. Now you get the camera matrix. From the camera matrix you can get all sorts of information like camera positions, camera direction, and so on. Okay, so let's do that. Let's get that. In order to get the positions, you can use the function called crack transform, and let's see what kind of options you have. So if you want to get the position, I think you are going to use this one, crack transform. So if you want to get the translation value, which is the positions, you type 0 for C, this one right here. So, and TRS XYZ is the order of the translation, rotation, and scaling, and the X, Y, and Z coordinates. So I'm gonna go with 0, 0 for this one, and C is also 0. Pivot is, I guess it's okay with the origin, 0, 0, 0. Vector, pivot, rotate. I'm not sure about this one. I don't know if I need this. I don't think I need this one, so I'm gonna go with this second parameter set. 0, 0, 0, 0, and also this one 0, and matrix X form, which is the camera matrix. So 0, 0, 0, 0, 0, 0 for the vector, and camera matrix. And by doing this, you should be able to get the camera positions out of the transformation matrix. Now it's time to create the intersection ray, and the intersection ray is for each point on top of this primitive. Now, since for that purpose, maybe it's better to make it as a point wrangle and use the intersect functions for each point. So the ray is the goal is to the end, which is at P from the camera position. Okay, so this is the ray. Now let's try to calculate the intersections to see if it's touching or if it's at the backside or not. First of all, let's create the empty parameters, empty variables for the output parameter for the intersect function. Okay, now checking the second input, which is the original geometry, starting from the camera position, and create the ray direction, maybe multiply by some really big so that it will penetrate the geometry for sure. Big enough to penetrate the geometry. Then I'll put the parameters like this. Now in this case, I think there is almost 100% that it will intersect, but the things that I want to check is the distance between the intersected position and the original point position. If this is close enough, then if the difference is close enough to 0, then that means the at P is equal to interpositions, meaning you are looking at the front side point. If the distance is more than 0, if it's far away, then there's a big chance that the point is at the back side, because it means then if at the back side, then you already penetrated through the front side, right? Is it? I think. Wait, am I? Yeah, I think that's the. Yeah, it's already being penetrated through the front side if the distance is more than 0. So what I would like to get is only the points which the distance between the at P and interpose is close to 0. Okay, if it's more than 0, then just remove it, which there's a big chance that it's on the back side. I'm not sure if that makes sense, but let's see it by ourselves. Calculate the distance between the at P and the intersected position, and if the distance is close enough to 0, or if it's more than 0, then just delete it. Remove point. There you go. Now the resolution isn't that good. You are seeing a lot of glitches at the edge, but it is somehow working. Now I'm not sure if the range is okay here. Oh, yeah, this is better. It's getting better. Nope. So this could be a parameter you want to control as a threshold. It depends on the resolutions of your curve and the geometry. Okay, 0.005. No, 0.01. Looks good. Now you can see that the backside has been trimmed. Now what I don't like is these like stair-like edges, which happens because the resolutions is a bit too low right now. So I need to I kind of want to fix that part. Now what I could think of in order to fix that, one of the things I could think of is to create a resample node before using the convert line and make the lengths as small as possible, like 0.01. Now it becomes a bit more smoother in terms of these edges. But as a side effect, you are getting tons of points. Wow. That just happens. Okay, but it looks good. Let's go back to the camera positions, and looks pretty nice at this view, from this view. Right. Now, next thing I would like to do is to project it on top of the flat plane. Right now, as you can see, it is still a 3D geometry, right? So in order to send it to a plotter drawing machine, you do need to make it as a flat geometry, okay? Also considering like some perspective of the camera, because if you change the perspective, something really exaggerated. Oops. Change this to camera view. You see, you start to have a lot of distortion with the geometry, but you still want to flatten this out to the 2D plane, okay? That's our goal, and let's see how we can do that. So in order to flatten out, we need to retrieve all those information stored in this camera, such as resolution, focal length, aperture, new clipping, fog clipping, position, direction, and so on. Okay, so let's do this, shall we? And in order to get all those informations in a simple manner as possible, I'm going to use I'm going to refer to those channel names inside Vex. Okay. Now, let me group these together, and since this has been split it into a, oops, I don't want to change the camera view for now. Fix the camera view somewhere around here. Leave the camera lock. Okay. Now, right now, each primitive is single line, so I want to connect it back to a polyline, the longer lines. So let's do that. Create a fuse. Maybe I don't really need a fuse at this point. Polypath. Okay, make sure the number of primitive has been decreased. Yeah. And yeah. Now it's time to flatten this, project it onto the flat plane. Let's go back to the camera and let's do this. I think I also did this flattening projection part in some other live stream as well, but I forgot when I did that, so I'm gonna recreate it. I'm gonna use the point wrangle. Point wrangle. Yeah, okay. And flat projection based on the camera view. So first thing first, I do need to access to the camera again, so I'm gonna copy this part Maybe I can copy all those lines like that, and change the camera path to again operator path type parameter. Refer to the camera. Right now, at this point, I am getting the camera positions. Now, what I want to get now is all those additional information of the camera, like focal lengths, aperture, resolutions, near, far, and so on. So let's get that. Focal is, you can get that by actually accessing to the channel of the camera path. So cam path plus focal. I've checked the name before, so I know how it spelled, but if you don't know, you go back to the camera, check the parameter interface, and check what kind of parameters you want to get. If you want to get the focal lengths, go to the part where it says focal lengths, and you will see this name here, which is actually the name you want to refer to inside of X. Alright, I did check all that previously, so I know how each of the parameters is called, and the one that I wrote is gone. Focal is equal to CHF cam pass plus focal. Okay. Next, aperture. Aperture is equal to cam pass plus aperture. Next, resolution. Now resolution is a vector 2 value, so because you have x and y. Res. Now next you want to get the near. Okay, that's a lot of things to write. Far. What else? Okay, I think that's about it. Right, so next thing I would like to do is to create the perspective matrix. Since you are using the camera with the perspective, you want to use all those informations to when you are going to flatten the image. So let's create the perspective matrix using perspective function, and you are going to store all those information you retrieve from the camera, something like zoom, image aspect, pixel aspect, clip near, clip far. Yeah, I think this is enough. So the zoom can be calculated by dividing focal length with aperture. Okay. Image aspect ratio is a resolution x divided by resolution y. Pixel aspect ratio is equal to 1. Clip near is the direct value of this near value. Clip far is direct value from the far. So focal divided by aperture, and res dot x divided by res dot y, and 1.0 for a pixel aspect, near and far. You get the perspective matrix. Now you want to get the inverse matrix of this pers. Then multiply it with a NDC coordinate you get from the camera path. So you do need to calculate the NDC position, NDC coordinate positions for each point position inside a 3D space by using 2NDC function using the camera width at P, and multiply this NDC position by the perspective to fix the distortion, and make this back to the world point position by... No, this is just the result of the try and error that I tried out when I have wanted to flatten the image, so I can't really explain why these steps really works. I gotta study more with those matrix calculations in order to understand it fully, especially this NDC part. From NDC, I want to make back to the space world. I really hate the way I need to write like this in a string. Okay, and hopefully this will work. Replace the current point position with position and make sure that you are not getting any Y value. So make this, or maybe Z. You don't really need the depths, so make the Z value to 0. And spell mistake or something. Invert. Right. Now it's not changing anything. Okay, I do see something, but it's not the things that I expected. Okay, I think I did something wrong somewhere. Let's see where. And oops. Okay, I don't want to lose the result. Please. Okay, let me save it. Okay, let's see where I did wrong here. Gotta make sure if I have got all those values correctly. Okay. Focal divided by aperture, resolution next, divided by... I'm not sure, there might be a chance that this could be an integer, so let's make sure this is a float. Okay, new for invert perspective, NDC position to NDC, camera pass. Okay, let's forget about multiplying perspective. Okay, now I see it. So probably this perspective calculation is somehow wrong. Right. Now, meaning I might getting something wrong with these value. Let me check. Focal. Focal, getting correct. resolution near, far. Okay, let's check everything. Okay, far as looks okay, focal looks okay, aperture looks okay, near looks okay, resolution looks wrong. Damn. Okay, I know why. That is because I have used CHF. Gotta be CHU. Okay, now I got it. And if I multiply the perspective, now the distortion is fixed. And I have got the right projected lines. Nice. This way. Okay. Looks good. And that's all about it. I mean, now you can use something like transform to rescale the stuff, because right now it's pretty small. The size is equal to 1 by 1, somewhere around 1 by 1. So if you think it's too small, then multiply it, rescale it to something big enough. Right. Maybe that's too big. Okay. That's how you could create the line drawings flattened out. And finally, what I always use is the process as a process in order to export it into, let's say, Illustrator. You cannot directly export any kind of geometry out of Houdini to Illustrator. I mean, it seems like it does support exporting .ai, but I couldn't re-import back to AI Illustrator. I also tried DXF, which most of the time it should work in Illustrator, but it also didn't work in my case. So what I have done is first exporting the geometry with a IGES, which is a common nerves-based drawing format for curves, which could also send surfaces as well. And after saving this to IGES, I'm using other CAD software to convert it into AI files. Since AI Illustrator doesn't really accept IGS as it is, so I do need to convert this something like Rhino to convert IGS file into a AI file, which is not a smooth like workflow. So if you really don't like that workflow, then there is a chance you could export those curves into SVG. I think Entagma have created the tutorial to export lines to SVG previously, like this, importing and exporting vectors from Houdini. Or you could also use a third-party plugin for Houdini like AE, live, which have a SVG export function or node. This one has the SVG export node included inside a library, which also works for Python 7 3.7, and which also has a bunch of useful nodes as well, so it's pretty fun to use. I'm not sure if you can still use it in 19.5. I think it's not been tested, so I'm not sure. But if you are okay with using Rhino or something like that, then just export it to IEGS file format. Then import the curve to import the curve, export it to IGS, to Rhino, and export it back to Illustrator file, something like that. Then you'll be able to open it inside the Illustrator. Which is really not the smooth workflow, but kind of works. I guess using the SVG way is much smarter. But SVG has some also limitation as well. It doesn't accept the NURBS curve. I mean, you could convert this into a NURBS after this, like using convert to NURBS curve or Bezier curve and export it to IGS. And you could also convert this back to a Illustrator. The benefit of using NURBS curve is that you can use less number of points to create a smooth curve. Okay, so meaning you can have the files with less size with the NURBS curve. So that's the benefit of using, I guess, IGS. Alright, so let's try opening up the file that I have just created. Where is it? There you go. The line thickness might be too thick. Where is the control tab? Okay, I'm not really used to the Illustrator. I thought there were a controller tab on the top. I don't see anything. Oops. Okay, well, at least you can see that the file has been opened. And if you have a plugin with the, if you have a connection with the Axis Draw or any kind of plotter drawings, you could send the drawing from here, like that. Okay, now let me see if you guys have any questions or anything. Maybe not. Okay. So I'm pretty okay with this result, but one thing that I would like to try out is to customly modify this contour. Because right now it looks okay, but let's say I want to, based on the position of the lighting, I want to make the gradient density to the curve. I want to make the density of the curve gradient. Let's say where the shadow hits, where the light hits to the surface, you have less number of lines. Where there is a shadows, you have tons of lines with the dense lines to make it look like it's been like occluded or shaded based on the light. That might be interesting, right? And to do that, what you need to do is to modify the UV value, the U value, where it's being used for this contour mapping, right? Where it is controlled somewhere around here. Okay. So let's try that out. Let's consider what kind of parameter I need to add the density information to this map. Okay. I am still going to use this value attribute on the vertex to create a contour line, but by modifying this value a little bit based on the light positions, I might be able to create the light density on top of the surface, or the shading on top of the surface with the lines. Okay, sounds interesting, hopefully. Okay, so let's see how we can do that. But I think I deleted something. Okay, so in order to do that, let me think. First thing first, I need to have the light position. So let's get that. It could be anything. Maybe I can just add 1 point, or maybe control point, control, which doesn't have, which I can move around. Let's say this is the position of the lighting. Alright. Let's consider I am going to create the point light, the simplest point light. Okay. Damn, it's pretty hard to control. Just want to move it. Okay, so let's say the point light is somewhere around here. Maybe where was the camera position? Okay, so the light might be better having stayed somewhere around here. How's that? Okay, so let's say that light is somewhere around here, so we are having the light being projected at this point to omnidirection, and there should be some shade shadows somewhere around here, 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 and so on. Let's try to calculate that or estimate that inside this UV map. First, I'm going to get the point position of the lighting. And estimate the direction from the point light to each of the points on a vertex. Now the vertex point position can be retrieved by at P, I think. I hope. Yeah, I think. So the direction is at P minus light position. Let's normalize this. Normalize this, and in order to calculate the strengths of the light on each point on a surface, I can calculate the dot product between the direction and the normal on top of the surface. Now each vertex, I'm not sure if each vertex has the normal. Yeah, I do have, so that's fine. Now that I get the normal dot product on each point, what I want to do is to make this as a part of this value. Okay. Now if I replace the value with this dot value, which is in between -1 to 1, so let's replace this to 0 to 1. Let's see what happens. The color map becomes something like this. So this is where the dot product is equal to 0, is 1. And if I look at the contour line, processed, this will create the line look like this. Which direction am I looking at? Like that. Like that? Forgot. Yeah. Now, as you can see, it is those line direction is based on this light, the strength of the light on a surface, which has been calculated with the dot product. Now this still hasn't shown the shaded value to the surface. So what I would like to do is to modify this value based on the dot value that I have just created. So in order to do that, what I am going to do is, let me think. Let's try adding this dot value, see what happens. Now as a result, something interesting happens, but there is a problem because the range becomes different from 0 to 1. So in order to be able to use the range that has been modified, I'm going to recalculate the minimum and maximum attribute value. by using attribute promote to promote the minimum from the vertex to the detail, checking the value, get the minimum value, also get the maximum value. Like that. And go to the contour line, get those minimum maximum information from the detail. Okay, let me make sure that the value has been created. Minimum maximum, yes. Detail 0 0. Okay, and let's see what it would create. Now looking a little bit better, you start to see some kind of a gradations here, which is still not so obvious yet. So in order to make it a bit more obvious, what I could do is to try out all those simple calculations to those added dot product value. Something like, where was it? Here. For example, you could try changing this value to 2, making these bigger or smaller to see the differences. Now you do see a lot difference with this smaller value, but it's not a clean gradient, so I don't really like that. So instead, I'm going to consider remapping this value with the ramp parameter. And see what it would create. Now let's check the color and get the detail. Minval. Detail minval 0. Max value. Alright. Okay, I can kind of simultaneously see the result of those modified value here using this color map. Might be a guide. Okay, where did it go? Okay, I have this ramp parameter, and let's check. So where was the, how did it look like in a view? Okay, like this. So let's try to change these curve and see how it's going to change those maps. Okay, it is changing something. And if I look at the actual lines that I get, you start to see some dense curve on the side where the shadow is strong. and you see a less curve on the surface where the light hits. Okay? Maybe this is not that obvious, so let's change the point position for the lighting. Shall we? So, oops. It's pretty hard to control. Right. How's this? Let's try with these setup. See what happens. Okay, not sure if it has changed anything. Maybe if I flip it to the other way around. Something like make this 1 and make this 0. Might give you not really. Okay, one thing I want to make sure, am I getting the right value? Am I getting really the point position? Okay, it does being retrieved. The position from the second input is being retrieved. Yeah, the direction, the normal. Yeah, looks fine. Maybe instead of using the point light, I might just want to use the directional light instead. In those cases, I don't need this. And instead, just gonna wait a minute. Maybe I do still need it. Change this to axis. Yeah, this could be used. And okay, where did so what I would like to do is to use this angle of this controller to, or maybe that's too much. I'm just gonna go with the parameter because that will be easier. So instead of having the light source, I am going to use the vector value, the constant vector value as a sun. Okay, and just use it as a sun direction. I'm gonna test with these value here and normalize this. Okay, now let's see what happens. And go from 0 to 1. What about 1 to 0? Interesting. Interesting, but no. Probably what I could do is to clamp this dot product, which is right now in between -1 to 1, but I can just use the clamp so that it's in between 0 to 1. And use 0, 1 instead. Not as I expected. No. Maybe not. Maybe I still need to. Or maybe I can control the value here. This is itself is interesting. Yeah, so I do see some gradations based on the dot product on a surface. I don't really know if I like it. It's a bit hard. But what I wanted to show is that you can customly modify the gradient on a pipe. Interesting. Interesting. Maybe I can clump this a little bit. Well, there are a lot of things I guess I need to explore to get the best result. But this is kind of a workflow you could try out in order to create this kind of a shading. Right? It's not just straight, constant contour, so it will create a bit more interesting result in the end, hopefully. Yep. Okay, that is pretty much it for today. I've already tried printing or plotting one of the results that I created using this method, using the machine that I have, and it went pretty fine, pretty well. I have posted the result on the Twitter, so if you are interested, you could check that out. Let me see where I can find it. I think I posted somewhere. Yeah, this one. Like that. Yeah, I used just a bowling pin to draw this with the machine. Went pretty well. Yeah. So with this process you could do the same if you have a machine. Okay. That's it for today. I think I haven't promoted all those parameters that I created for flattening and so on, so I'm just gonna promote these and we'll end this live for today. If you have any questions or anything, let me know. And I am been doing this for 3 hours. That's too much. Okay, UV mapping. So this, not sure if I want to bring this to the parameters, so I'm gonna skip it. Go to the contour line. Okay, number of contours. All right. Resample, yeah, this is important. Final res. And trim backside threshold. This is important. Trim threshold. Camera path. Yeah, this is important as well. And this is just the camera path, so I can just copy the same one. Okay, that's pretty much it. Let me copy this path here to here. There you go. And this is it. The same process that I showed you here, contouring, projection, trimming on the trimming the backside and projecting on the flat plane, could be used for any kind of geometry. Okay, so it doesn't have to be things like this. You do need some creativity, what kind of attribute you want to use to create a contours in this case. Right, so that's your uniqueness. As well as the choice of your geometry. Right. and also it doesn't really have to be a contour lines. It could be just a bunch of circles on top of the surface or anything, any kind of curve related value, curve related geometry. Okay, this is just one example, but the trimming on the backside and the flattening could also work for all those curve geometries on top of the surface, so you could try that out. Right. Thanks for all the comments. I have a questions. What if the base geo is only deformed along two axes? Looks visually like the depth is causing an issue. Looks like depth is What if the base geo is only deformed along two axes? You mean which part of the question is that? This one? I'm not sure what the question means. What if the base drill is only deformed along two axes? You mean twisting, bending on two axes? Looks visually like the depth is causing an issue. I'm not sure what the question is. Sorry. Let me know if you have more detail. Okay. As always, I'm going to upload the files to the you're welcome. Welcome everybody. Thanks for the comment. Arigatou gozaimasu. What was I about to say? I am going to upload the files as always to the GitHub, and I'm going to paste the link to the video description page of this live stream so that you can download as soon as I finish the live. Okay. And I'm also going to post the files to the Patreon page of myself, so if you are kind enough, please support me on the Patreon. Okay, that's it. But everything that I have created can be downloaded free for from the video page, so please feel free to use for your own purpose. Okay, that's it for today. Sorry for the long live, but I had a fun. Yeah, and I will see you guys on probably sometime next week with some different topic. Okay, that's it. Thank you very much, and see you. And animation didn't really mean anything with the plotter drawing. Maybe you could have a series of drawings, picking some of the frames. That might be interesting. Okay, that's it. Good night. Good night. Good night.